My name is Alexander Sokol. This is day 4 of the Enterprise Software Development and Python course by CompatibL. The lecture will be, as usual, 90 minutes, and we will be issuing, a certificate for the successful completion of the course. The certificate will be based on a quiz. It will not take a lot of time, to do that, but basically only those who pass the quiz and do a little practical exercise will get a certificate. And if you're interested in that, please stay to the end because I'll be talking about it toward the end of today's lecture. All right, so let me get started. My colleagues, as usual, will be monitoring the chat. If you have any questions, please ask them in the chat, and they will either answer directly or they will alert me, and I will answer. 1 second, so looks like a few questions already. Just hellos. Okay, great. All right, so let's get started. Right, first of all, let me share the screen. One moment. Today, the topic is queries, REST API, and web apps. But what we'll really be doing is looking at the architecture of a modern cloud application, which has microservices that has all of the proper components. It runs in the cloud. It does not have servers. It has endpoints, cloud endpoints. This is, what we're trying to build. This vague shape around here is supposed to be a cloud. I even put a little word cloud here in case it's not clear. The users are, of course, not in the cloud, but on Earth. And they're talking to the web app. And the web app is talking to the REST API, right? So in other words, a web app receives, page requests from the users. Sometimes they're just looking at information. Sometimes they're interactive, or more often they're interactive with the page. For example, they may be, doing some queries based on inputs, or they are doing some actions that will lead to changes in the database. But the web app does not go to the database directly. It does not receive streaming data directly. And this thing here is a fire hose to indicate that it's a lot of streaming data coming very fast. The rest, the other REST APIs. But the key aspect of the architecture is that, or modern cloud app architecture, is that, and actually that aspect is not that modern in the sense that it existed even before the cloud. That the web application, right? So web app, that the application that serves pages and provides interactive experience in the browser or another front end, a mobile front end perhaps, to the end user is not the same application that actually does the heavy lifting, works with databases, receives streaming data, and so forth. So there is a 2-step process here. So the users go to the web application. It goes through RESTful services or rather endpoint, right? So in the cloud, the servers or applications become endpoints. So the users go to this endpoint, and it talks to the REST endpoint, and the REST endpoint then talks to everything else. And the reason is that if you have a different database, if you have a different streaming provider, you will not need to change, first of all, this application, only that one. That's one reason. And the other reason is that there is I called it a firewall. It's not actually more complex than that, but there is essentially enhanced security outside and less of an enhanced security inside. So outside, the users cannot cross this. Let's just interact for 1 second. So I need to make my colleague Anastasia co-host so she can reply to questions on my behalf. Okay, Anastasia, you should be able to.
Hello, everyone. Yeah, thank you.
Okay, good. Yeah, sorry, Anastasia was in the client meeting, so couldn't join earlier. All right, so let me continue. So the key thing here is that first of all, when you're making changes, it's easier to make them here and not have to make them here. But much more importantly, on the web security, a lot of security is related to being able to call from inside to the outside, but not vice versa, right? So in other words, if I am inside the firewall and say inside the security perimeter, I can still make calls outside to various services. I can, for example, get market data. But once you start enabling people from outside to make calls inside your perimeter, and the users, of course, want to make call to the application, That's where security gets a lot more complicated, because these users may be malicious and they may start doing, not what they're supposed to do, but trying to hack into the system. So that's why the web app, of course, you have to enable to come in over, for example, HTTPS protocol into the web app, or into, using another protocol that a mobile application on a mobile device would use. But only the web app can go through this dashed line, which indicates, again, I marked as firewall. It's actually, it's more generally can be called security perimeter. So the users cannot go here. The users can only go to the web app, and the web app has a token, has a security token, which is issued through a very elaborate process. And that security token enables the web app to make calls inside here. So we're not going to deal with security here. And also, we're not going to deal with streaming data. So if this is a castle, then what we will build today is a sandcastle, right? So it's a sandcastle. It's not as impressive as a castle, but it does have all of the right turrets and moat and everything in simplified form. So this is the user. The user is you. The whole application will run. You can actually deploy this application to the cloud, but today we'll simply run it on a local machine. So this user is you or me, if I'm running it. We will have a web app that's separate from the REST endpoint, that's separate from the database, right? So we're not going to build an application that just goes to a database. We're going to build two applications. One receives request for a web page and goes to the REST API, retrieves the result, returns. And the REST API, when it receives this request, will go to the database and return the result. And in the castle, we have HTTPS here, right? So secure HTTP protocol. And HTTPS, usually it's a good practice to do it inside the perimeter as well, just in case, just in case there is a, hacker who adversary who penetrated the perimeter, they still would not be able to eavesdrop on traffic. But however, sometimes for performance reasons, use TCP/IP or UDP. Right, but here we'll be using just straight HTTP, so we will not be dealing, the format of full lectures of this course. We will not be able to deal with security. That's a topic that probably requires its own course. And we'll use HTTP, we use TCP/IP, and we just have one database, no streaming. Right, but it will be a realistic application. And the application we will build is something called a trade blotter. So trade blotter is when you're making trades. You need to register them, right? So right now, everything happens electronically, and the trades are submitted to databases. In the past, traders called each other on the phone, and the back office, so people who worked with the back office, where their job was to make sure that if trader calls another trader in a different bank, and by phone they agree to a trade, and all of that is on the recorded line, then they go and enter the trade into the system. So what we have is a trade blotter. So when traders do the job, they trade, right? By the end of the day, they have a list of trades that they executed, right? So they maybe enter it into a swap agreement with someone. Perhaps they bought a bond or sold a bond. So what we will do is build an application that makes it possible for you to see this on a web page. It's going to be a very primitive web page, but we will be using modern tools that actually are exactly the type of tools that real production applications use. We're just going to use them in a simpler way, and maybe access about 5 or 10% of their functionality. But these are real tools that people use every day to build web applications and REST APIs. Any questions so far in the chat?
Not about the slides, so you can proceed.
All right, sounds great. So here, let's start building our sandcastle. And I hope with what you learned today, eventually you'll be building amazing castles. All right, so there are three things that we'll be doing, right? So first one is database queries, right? So during the last lecture, or previous lecture, next to last in this course, lecture 3, we learned how to record the data in a database, and we learned 4 styles of representing the data. Actually, for this presentation, I renamed them just to make it more clear. There's one that's relational for traditional relational databases. The one which I call deep, I renamed it to tree on this set of slides, just so it's more clear that it's hierarchical as a tree. Then another one, I called it frame because it's very similar. If you're familiar with a data frame, which is a concept in statistics. Basically, data frame is a two-dimensional table, right? So it has column, it has rows. So it has our language has it. All of the statistical packages have it. Python, of course, has it in the pandas package, which is a very well-known package working with data. So I called it a frame because it stores data about legs for the swap in a two-dimensional table. Right, and finally, wide, which is something that I implemented on top of MongoDB. But there are some personalized databases that actually, are optimized for the style, called the wide column databases, and one of them is Cassandra, which is an open source database. That's probably the most well-known example. All right, so today we'll learn how to do database queries. And specifically, of course, all of these databases have their own kind of standard query language that you essentially execute in any programming language a set of commands, which may be SQL commands for relational databases, or for other databases, there is usually some proprietary way to specify a query. For example, for MongoDB, it's a JSON document. But we will learn about a different way to do queries, which is related to this object document mapping, object relational mapping, when you represent data in a table as an object, and you work with the database by calling functions on these objects, right? So we'll learn today how to do the same thing for the queries. All right, so first of all, just a quick recap of the data representations that we used. We'll use two of them when we look at queries, and only one of them when we build the app. So the tree is when it's a hierarchical JSON document. So blue is, so there are two traits here, both are swaps. So swap is a financial instrument or a trade, which has two legs, right? So it has one-to-many relationship with legs. One swap, many legs. In our case, two, but it could be 3 or 4. So blue is the first swap, trade 1, which has hierarchical document. Here it has an array of legs, and I can show the same document in a database in a moment. So it has an array of legs, and each leg is a dictionary, where first dictionary has fixed type in USD currency, second dictionary has floating type and euro currency. All right, oh, sorry. Right, so now the second representation is data frame, right? It's a shallow representation. And the reason it's shallow is only good for shallow data because it stores the data in a two-dimensional table, and it's specifically two-dimensional table, so you cannot make it three-dimensional. So this particular representation is okay for the swap with two legs. But if leg has other hierarchical data inside it, and actually it does, it has something called cash flows, which are individual payments of the leg, right? So then it would not work, but it does work here. So in this case, you have an array of types in an array of currencies. Okay, so then there is a white column format where everything becomes flattened, but very white, right? It's called a white column database. Sometimes this type of a table called mile white table, meaning it's as white as 1 mile. Right, so here all of the fields are at root level, but the columns have also additional numbers. And Cassandra specifically has various ways of working with these columns as a group. Right, and finally, relational representation, where instead of a one table, as when all of these other databases, we have two tables, one for swap or the trade and one for the leg. And in order to reconstitute and retrieve the swap, we need to call a query to find all of the legs that belong to the swap. And if we need to filter, we have to do something called a join. Right, okay, so the hands-on session, the first hands-on session of today, will be to do queries using ODM and Oram. And each of this query, syntax languages, I wouldn't even say language, but each of these query APIs and the syntax of the queries in that API, each one of them is specific to the package, but they're all conceptually the same. So the key thing to realize here is that even though if you use Mongo engine, you have one type of query. If you use SQL Alchemy, you have another type of query. Django, which is an older web app framework, also services framework, it's very heavy and it's not as widely used as it used to be, right? So it used to be the only game in town. Now there are lighter, more modern frameworks, but Django also has its own object relational mapping with its own query language. right? Also, there are other languages. Practically for every database, there are multiple choices. And each of these object relational mappers, frameworks, or object document frameworks have their own detailed approach of how to do a query. But conceptually, at a high level, they're all the same, right? So they all use the same concept, but they have slight details in the syntax, right? And this has to do with the fact that Python, unfortunately, again, and all comments or concerns about this should go to Guido van Rossum, the inventor of the language. So Python does not have we did not have initially first-class kind of expression syntax with Lambda that has type safety. In fact, even the Lambda syntax has evolved and appeared from pretty late in the game. So there are languages in which there are lambdas, that's native part of the language with type hints and full, basically with all of the features that the rest of the language has, not as something that was added to the language later. And with these lambdas, you can do expressions. And in these languages, you have a lot more commonality between how these frameworks work, because there is a standard way to say this field should be less than, let's say date range. Date should be more than that date and less than some other date if you're looking for the interval, or trade ID should be equal to something, or leg currency should be equal to something. So in Python, just because there wasn't for a while Lambda, and there wasn't really still, there isn't a standard way to do expressions, each of these frameworks invents its own. But once you go through this layer kind of confusing syntax, you realize that they all do in the end the same thing. So it becomes very easy to switch from one to another. So we don't have time for multiple. So I'm going to show the Mongo engine UDM queries. But all of the other ones are conceptually the same, even though the syntax is different, right? But once you understand the concept, you'll be able to quickly learn the new syntax. And we will learn about how to query for fields at root level using wide data representation, how to query for fields deep inside lists and dictionaries in tree data representation. Sorry, there's a typo here. There shouldn't be a dot. And the role of database indexes in query performance, even though I'll probably just mostly talk about it because we need to finish building our sandcastle and leave some time to talk about the certificate in what's next. So I'm sorry, let me switch to PyCharm. Any questions so far?
Not yet.
Okay, great. All right. Let's see. I thought I launched it. Okay, yeah, it's here. All right, so we're going to go back to the examples that we're looking at, in the previous lecture, and we start from white, right? And what I did is I made the examples, I added queries, and I made the examples a little bit more elaborate. And let me just quickly go through that, just so you can see the structure of the example. So I made this example a PyTest test, right? So a test using PyTest framework. In PyCharm, first of all, if you're developing in Python or in any other language, you should have a complete set of automated tests, and then you should have something like Jenkins, basically continuous integration framework that would run the test continuously. That's what we discussed in lecture 1, when we're talking about development practices. These badges on open source software that says building, right? All tests are, fine. So to earn this badge, all of your commits, or rather, if your latest commit breaks something, then this badge will show no, failing, and that's actually kind of a bad thing for the reputation of your package, whether it's commercial for your employer, for your future employer, perhaps, or open source. So, well, we have tests. Again, we didn't set up continuous integration, even though after the course we might, because this is all on GitHub. But right now, we can run them in an automated mode, right? So I'm going to run it. And by the way, the way you run it in PyCharm is that in settings, you can go and say, basically the test tool, right? And there is a test runner is auto detect. So they have PyTest, they have nose tests. That's, I think, well, the two key ones here are unit tests, which is the, the elder and the grandfather of all of the grandparent of all of the other test frameworks. And PyTest, which is a more modern one than Pythonic. Unit test is so old that it uses camel case for methods, right? It's amazingly old. And a couple of others, right? We have all the decks, so we're going to be able to run it. If I'm going to run this test, all of them will run in parallel. And for that, we set up, I'll explain in a moment, how to make sure that they don't interfere with each other. And all of the 25 tests passed, which is good news. Right, okay, so now the test that we're interested in right now is this test for white data formats. So white prefix here means that we're using white data representation, where everything is flattened and each column has one value, right? So there's column for leg 1, column for leg 2, right? So it's like Cassandra does it, even though I'm storing data in Mongo. And also there are these two functions here, set up and tear down. You can make, so normally, and that's when, goes back to some very ancient web frameworks for C++. So in a test, it's a class, and the function called setup is executed before the test. Then the test is executed, and then tear down function is executed. And in PyTest, you can actually put something called a fixture. You can make a decorator that will make it run directly. But my setup function does not have parameters. My tear down function does. So in this case, because it has parameters, you can pass these parameters. You can do some magic here, but I'm just going to call setup and tear down directly in the test. That is another way to do it. So PyTest makes it possible to automate calling of these functions before and after the test, but we don't have to use it. So test CRUD, right, is a test for CRUD. Everybody I assume knows what CRUD is, right? So these are the key operations for the database, right? Create, retrieve, update, and delete. So we're going to test how this database works, and as part of retrieve, as part of R here, we're going to do a query. So first of all, setup call, which is a function of this class, will return a tuple, right? So in Python, in many other languages these days, you can return more than one value from a function, right? So it returns connection alias and the connection itself. Okay, why you cannot get connection alias from the connection, is surprising, but that's how Mongo, at least I wasn't able to find it in Mongo engine. If anybody knows of a way, please let me know. But we're just going to return it separate. And connection alias is separate for each database. And it's very important that we separate them, because otherwise all of these tests running at the same time will try to read and write in the same database and will interfere with each other, right? So connection alias is one way that we can make tests separate. Okay, so then the second thing is that we're using approval tests. And approval test is this framework in which instead of laboriously, we're going to output a lot of data from these queries. So if I was using the normal unit test kind of style, where I check with assert that each returned value is the correct value, I would have to, let's just look at the output, right? So the output is right there. So this is the output of our query, right? It has, 6 values here, 4 values here, that's 10, right? 11, 12, 13, 14, 15, 16, right? So I would have to write 16 asserts. And if I had the bigger query that provides more comprehensive testing, and I definitely would if this was not a course, right? If this was not a, we have open source projects and we have commercial projects. And of course, any database adapter is tested on much bigger set of data to make sure it's all correct, right? So in fact, this query returns just one record, and it's good for a course because we don't want to examine 10. Right, but the real system would have, of course, more. So approval tests, which I highly recommend, and again, this is a concept that you save your correct result and then check that the result is the same, right? You don't have to use the approval tests package. So this package is from people who did a lot to popularize this approach, and they're making it available not only in Python but also in various other languages, including C++, Java, and C#. But you don't have to use the package. It's very simple. You can do it yourself, right? And we're going to use this package, right? You don't have to, but we will. And we're going to just check that the result is the same as before. Okay, so now after we inserted the records, which is what we studied on Monday, we're going to query them. So let's look at the queries, right? So first of all, how do you get access to the query? You start from the class in Mongo engine. Again, in Mongo engine, you start from the class, you go dot objects, right? And then you go dot, and objects offers you, let me just see if I get autocomplete, 1 second. Yeah, so object gets you basically all the things that you can do here, except just see here. Actually, you know what? Yeah, okay. So yeah, no correction. Yeah, so actually it does not. Normally, the best way to write interfaces, so it actually after you hit dot, it tells you everything you can do. But in this case, order by is not offered. So it just depends on how the package is implemented with inside dynamically or statically. So you can call order by function, right? So order by function, as the name implies, will order the result by trade ID, right? So this is a query. If we did that, it will just return objects in random order. When we do that, it returns them by order ID. Okay, and then once we get the result, and let me just step with it through the debugger, right? So once we get the result, so I'm going to step with it through the test with the debugger as opposed to just run, right? So it stopped here. So then it stopped here. Let me just remove this breakpoint, so I don't really need them. And now I should remove that one. And now we will come to, so we inserted the records here. So all trades, right? So what happened here is that if you look at all trades, this is not a list, right? So it is an iterable, right? But it's a query set. So in Python, a lot of things that behave like lists, they're not actually lists. And specifically in this case, when I'm working with a database, I don't know if I get 3 records, 1 million records, or 100 billion records. And 100 billion records is definitely within the realm of possibility for modern databases. But I don't want to store 100 billion records in memory, because especially in the cloud, desktop, actually laptop, my laptop actually has 64 gig, right? But in the cloud, you normally don't want to have a lot of RAM. That's expensive. So this query object will pretend it's a list, and as you go through the items of the list, it will dynamically retrieve. It's lazy, right? So it's lazy evaluation. Dynamically retrieve remaining records. So right now I can just simply iterate through it, but sometimes I will pass it somewhere and it'll say, "Oh, I've expected a list, but it's not." In this case, you just put list in parentheses and it will work. Any questions so far?
No, please proceed.
Okay, right. So let me just open this result, right? So 1 second. Okay, so we're going well on time, right? So this query will return this, right? So it will return. Again, it returns the entire trade, but I only output trade ID and trade type, right? So the first 2 are swap, the third one is bond. That's what we are recording in a database, right? So so that's what will happen here. Okay, so then here I want to return only the swaps, because once I start filtering, right? So we'll learn how to filter by certain attributes of the trade. But each trade has different attributes. For example, swap has legs, but bond does not. They are both inherited from trade. So swap and bond have some fields which are common, and we put them in a trade object, and have some fields which are separate, and we put them in a swap or bond object. So swap is derived from trade, bond is derived from trade, common fields are in trade, separate fields are in each class. Okay, I have a question. There is a question. How interference between different queries to database at the same time as possible? Can you tell or show an example? I'll show you an example. Basically, what happens there is unless you basically there are 2. Let me just answer quickly. I don't want to. I don't know if we have time to look at it, but so let me answer. And if we have time, I may be able to show it as well. So there are 2 ways in which you can interfere. Okay, so first way is that you have the same database and you're doing different tests on the same database all at once. In particularly in Mongo engine, the database is actually, and that's actually, I would say, not a great feature, right? So it's a good object document mapper in other ways, right? But that's a feature, I would say, sometimes you're fine with it and sometimes you're not, right? So in Mongo engine, if you go into trade key, right, which is the root key of the hierarchy, it has this DB alias white. In this DB alias white, if we go to the database of, so a second, just switch to the, you still should see the screen, right?
Yes, all good. We see the code.
Yeah. So let me just reload data, right? So you see that there is this white table here. Okay, so that is the, so we have a server and white is the name of the database. Admin configure local is something that Mongo server needs to function. White is a database that we created. White trade key is the name of the table. That's the name of the base class. It just happens to be have the key suffix. You can actually rename it. I didn't want to make it very complex. And this is our three trades that we just looking at, right? So and because it's a white structure, there is no plus here, right? So if you look at JSON, it's all on the same level, well, except this object ID. If you look at table, you don't have to click through, right? So it's everything at the same level. Just move, sorry, the zoom thing out of the way. Right, so the table name is white. Okay, so now imagine that you're running two tests on a white type at the same time. I only have one test. So what will happen here is that they will interfere with each other, right? So if I go to white crude test, and I, instead of test crude, I make like test crude 2, test crude 3, and so forth. They will all be writing in the same database. I cannot change it because the database name is hard-coded into the class. That's not ideal. You can actually change it because in Python, you more or less can change everything in your code as it's running because it's an interpreter. So this assignment of database type, this meta attribute, right? I can actually change it dynamically. It just this would lead us toward kind of a very deep Python as opposed to using Python for enterprise development, right? So it would lead us away from the purpose of the course, right? So, learning how to do that. Maybe we'll do another course. Actually, after the course, we'll do a quiz, by the way, for all participants about what other courses you'd like to see from Compatible. So, if advanced Python course, not enterprise in Python, right? Development in Python, but just advanced Python course. If this will be the choice, I'll be talking about how to do things like that, right? So one way it can do it is that multiple tests right in the same database. And as one of the tests loaded the traits and started to do something, another test which just wipes out all the traits, right? And basically the second test then fails. So the first test to start and fails. So that's one way, right? Second way, which is what happens with SQL Alchemy here, is that it does not allow you to open multiple connections at the same time unless you specify an alias. So that's a different problem, right? So it has nothing to do with the databases. It's just the server tells you that you need to only one connection unless you provide the unique alias. So there are two ways, basically. One is that you may be just writing from two tests in the same database and they will corrupt each other's data. And the other one is that the two connections have to be identified so you know which one is which when you are working with the code. And generally, I very highly recommend not sharing databases for tests, even if you use with different types and so forth, because the safest way of doing it is to create a database for the test, make sure it's a unique connection, unique database, it runs, right? Then you delete the database because then it's clean. It will not interfere with anything else. You always get the right result. All right, so back to, it was a very good question. So any other questions so far? Okay, so if not, let me go back to the code. Okay, great, right. So now we have a trait, right? So now if we do this, right, if we get our objects, so objects is our access to the rest of the database functionality. So this is our class. Once you make the class, once you derive the class from the Mongo engine base, it acquires this object attribute. And that's our gateway to database functionality. So if we access this gateway, not through the trait, but through the swap, through the derived type, it will only see the swap objects, right? So if we run this query, then we already ran it, right? So because it's recorded in this approved file, so it will then give us only two traits swaps. Why do I want that? Well, because if we're going to filter by something that's inside the leg, but bot does not have the leg, this query will fail, right? So maybe we're looking for particular currency, it will fail because it will not find any currency. Bond does not have legs, right? It only has one currency, right, of its payment. So so this is a very important feature that shows how Mongo database and other object document, object relational mappers make it possible for you to have essentially a hierarchical definition of objects represented in a database is a hierarchy. So you have the single table in which different types of records can live, swap or bond, which are both traits. But you can query, you can say, I'm going to query all swaps which have something in the leg, right? So say, well, in this case, I'm going to query the swap, I'm going to access my gateway to functionality of the database will be through the swap and only see the swaps. Okay, now let's see the query, right? So let's retrieve only those traits that have type white swap and have GBP as a fixed leg currency, right? Okay, we're going to have fixed leg one swaps. Actually, let me just show 1 second. Let me just go back for a second and show you something quickly. Right. So let's see what happens if we comment out this order by, right? So it may return the results in the same order, or it may not, right? So let's see what happens. The order is kind of random, right? So I don't know if it just randomly will work, right? Okay, well, it looks like it didn't, right? So let's see what kind of error we got. Okay, we got error from approval test library saying approval mismatch, received not equal approved, right? And it says approved file is here, received file is here. And we should be able to see them on Git, right? So this is the received file, but the reason I don't see approved file is because the approved file didn't change, right? So this approved file and received file. So let's look at the difference. So you can see that this trait is first with trait number 3, but here it's last. Why? Because in the approved file, that's the approved file. In the approved file is sorted. We remove the sorting. Our received file is in a different order, right? So this just happened to be the same, but not these ones, right? So what happened here is that we failed to sort, and the test showed the difference. And because the database does not guarantee unless you apply explicit ordering, the database is not guaranteed to return data in any particular order. So we're going to either, if this was just an update and a test, I would have copied received into approved and committed it with the message new correct result that we should now replicate. But this is actually not the correct result. So I'm going to comment again uncomment the ordering, run again, and hopefully now it will succeed, right? No, sorry, I didn't. I didn't. I think that there's a second one, right? So I did both of them. Yeah. All right. So hopefully now it will succeed. Okay, right. So you see green, right? And what happened is a deleted received file because if it's the same as approved, it deletes it, right? So that's how approval tests work. Okay, so now let's do something more complex and more fun, right? So let's find all of the swaps for which one of the leg currencies is the currency that we want to specify. Okay, so this is a white table, right? So it looks like this. So I need to check, and we need to find all swaps for which the fixed leg has currency GBP, British pound. So I need to find all of the records in which either leg type 1 is fixed and currency is GBP, right? So that's the second one here. Or leg type 2 is fixed and the currency is GBP. Well, there are none like that, right? So in other words, it's either the first leg fixed and is currency GBP or the second leg fixed and is currency GBP. So I'm going to make it with 2 queries, right? You can probably express it with 1 query, right? But that would get like really convoluted. And by the way, another thing is here is that I really should have checked for duplicates because sometimes you can have both legs as GBP and this will return the trait twice. So I didn't do it here, and really I should have, but that's not what we're showing here. So please excuse me for that. But strictly speaking, we should have checked for duplicates, right? So this query will return leg type 1 fixed and currency GBP. This one leg type 2 fixed currency GBP. Then we're going to say plus, and plus for lists in Python means concatenated lists. As you can see here, I put list around. So that's this example. If I did it without the list around, it would say that's one lazy query, that's another lazy query, and these 2 queries are so lazy that they cannot be added together. They're too lazy for that, right? So basically it will say, well, you're adding 2 queries. What does it mean? Does it make sense, right? So by putting list around the query, essentially this constructs a list by iterating through the query. So at that point, it loads everything in memory. It loads everything in memory. And if I had the 100 billion records, I would be in huge trouble. So I wouldn't do it, right? In this case, I would go and do this elaborate query that checks for one thing or the other. But because I only have a few traits, I can do it, right? And then we're just printing out the same traits. Now, so this seems pretty simple, right? But what is the syntax? So you see what it does here is that objects is actually here can be used as a callable or a function, right? So in Python, again, you can access the object itself. So it's like an attribute, but it can also serve as a function. It's all magical thanks to Guido and Rossum. And here it looks like I'm passing these parameters, right? So I'm passing parameter leg type 1 equal fixed, leg currency 1 equal GBP. So in Mongo engine, the way that they're asking you to specify the query is to pass query parameters to this object gateway, right? So essentially when you're getting the objects, right? So that thing returns the list. So if you don't pass any parameters, this will return the list of all swaps, right? Because we're getting it from the swap. But you can pass parameters, which when you pass them like that, it will interpret them as the equal query, right? So it's not double equal, right? You know, in languages like C#, there is something called LINQ, which is, you know, I would say, you know, maybe a little bit more better from a formal computer science perspective because it's a proper expression. And you would write 2 equals here. But in Python, there is no syntax like that. You see, you know, PyCharm doesn't like me when I do that, right? It just underlines red. So in Mongo engine, this parameter that you set to this value is interpreted as a query where this attribute is equal to this value. Even so, you know, it's a parameter, right? So it means that, but the syntax is that, right? Because you are passing the parameter that is somewhat. So essentially you're specifying parameter leg type 1 of the function, which later use the value of this parameter to compare to that attribute. Okay, so now if we run it, right, what will happen is you will get that, right, which is the only trade we have that has GBP as the fixed leg currency. You see leg type 1 fixed, leg currency 1 GBP, right? So it did exactly what we're supposed to do. Yes. Now the question is, this is equal, right? So how do you do other queries? Well, you do other queries in a kind of a strange way, right? By the way, also you need to make sure that when you use other queries, right, you can do equal on a lot more data types than you can do less. So some of the data types are not orderable or are very inefficient when you order. And in order to make queries efficient, you need to do something called an index, right? Which is you tell the database that a particular column should be optimized for sorting, filtering, and so forth, right? So if we have time, we'll go through that. But if not, it's right there in Mongo engine documentation, right? But essentially, you know, for any database, document to relational, if you're going to query a lot by a particular column, you need to generate something called an index, which is essentially is a dictionary that tells you exactly where a particular, you know, value starts, right? So if it's by date, it will record where each date starts and ends, so it can quickly retrieve the right tables instead of going through the whole 100 billion records. So in order to, if you did that, right, and you can then, and if your field is the one that you can sort by, like integer or date, you can always sort by this or double or floating number. Sometimes you can also sort by strings in lexicographic order, and sometimes you cannot, right? So that depends on the database implementation and on your flags. So, but if I could sort by strings, I could do this double underscore LT, right? So this parameter means that you assign value fix to this variable. And that variable, because it's of a suffix, will be then interpreted as a query that leg type should be less than fixed in lexicographic order, in alphabetical order, right? So lexicographic order, has computer science definition, but it's for ASCII alphabet, you know, it's same as alphabetical, right? So you essentially work with Mongo engine queries through this type of a syntax. And for flexible mapping frameworks, such as, well, Mongo engine is for Mongo, right? But there are others like Django or SQL Alchemy that for other databases. The advantage is that you don't have to learn any particular, you know, language of a database. You don't need to learn a flavor of SQL. Sometimes you work with the same API with a SQL database and a NoSQL database. And the most important thing is that it's Pythonic in the sense that you don't go and start inserting snippets of another programming language like SQL into your code, right? So it's all in Python. So that's how it works, right? So so let me now finish with that, and this test already it passes. So let me now switch to the tree representation, right? So how do we do the same thing for the tree representation? In the tree representation, again, reminder, the tree representation, the data is hierarchical. Okay, so first of all, let's run the test. And at the end of this test, let me just comment out the teardown so we can actually look at the data, right? Okay, 1 second. Okay, so now in our database tool, I'm going to reload the data, and we will now see the tree database. By the way, with the white database disappear because the test cleanup after itself. So you see that legs is an array of objects, and each object is a dictionary, right? So in JSON, it would look like that. Okay, so the question, how do you query for something that's inside, right? It's not at the root level, right? So it's not here, right? It's deeper. Okay, so in relational databases, this would be a join where you query one thing and you can combine with other tables and so forth. In Oram, right, or in this case in a document database, you can do the same thing for object compositions, kind of similar approach. And the way this works, let me just comment again. Actually, let me just leave it commented so we can look at the data. It doesn't get wiped out. Right, so the way this works is this variable, same approach, right? So they have the convention for how to specify a more complex query through a special way to compose parameter name to this function. Every time you have double underscore, it's a level of hierarchy, which could be a list or a dictionary. So in this particular case, lex double underscore 0 double underscore leg currency means lex index 0 leg currency, right? So that's how you would do it if this was a Python dictionary. But here it's just a custom parameter name. So every time you have a level of hierarchy, and it can be either list or dictionary, so the application knows about it, you do double underscore, right? So this means that the query is on that. And equal, again, means it's equality, right? So they write this, but think that, right? If we go, if we want to compare, we can go also LT, so less than equal, right? Sorry, with the tool double underscore. So that's how it works. So exactly the same thing, right? Swaps in which the fixed leg has GBP currency. Swap in which first element of the leg array has GBP currency as fixed type. Swap, these are all of the swaps in which the second leg is fixed and has GBP type. Then I'm combining them, and then once again I should have checked for duplicates, right? And I'm providing the output, and I can run a test. Hopefully it will pass, and we can see here that it did exactly the same thing, right? It retrieved this trait tool. Okay, now let's see how in the final thing, just before I really need to go to web applications and REST, right? So how do you do it when it's any leg, right? Well, it turns out that Mongo engine also has syntax for that, right? So this variable name, where, as you can see, I skipped one level. So what it means is that any element, right? So I went from legs here, right, to leg currency. And what it means is that leg currency is at any level deep inside the hierarchy. It's actually the previous query also worked like that, right? So I said legs level 0. So in Mongo, when you are specifying a field by which to filter, but the column that you specified is the document to list column, it will interpret it as or on any element inside. So you have, imagine you have a complex dictionary, right? And somewhere deep inside there is leg currency. So it will find all of the fields called leg currency and compare them to the query result. Okay, so that is the explanation why you may have noticed I put leg currency and I put bond currency, right? Let's go back to the data types. So you see I put here for the swap, right? For the I put leg currency, I put leg type, right? But for the bond, I put bond currency. If I put just currency, it will confuse the tool. Sometimes that's what you want, but that's not what I wanted here, right? So I wanted to make sure that when I'm searching for leg currency, there are no other currency fields. Sometimes it's like sometimes it's a third, basically sometimes collateral currency, right? So in other words, for the trade, there are multiple currencies specified as part of the trade contract, right? Some of them are currencies in which the payments are made, some of them are currencies in which the payments are converted, and so forth. So if you're going to use this feature of Mongo, and generally to avoid bugs, it's a lot better to be verbose, right? Don't say currency in a leg, right? You say leg currency, because in some cases it's actually not clear, like where the field is. So more, you don't want to have, of course, fields that are 25 characters long, but it's better to be verbose, right? And that's the reason I did it this way. Okay, so this and that's the last thing on the queries, right? So what this thing will do is that it will find any leg currency inside that is GBP. So in this case, it's not looking for a trade where the fixed leg has GBP currency. It has a trade for which any leg has GBP currency, and it will return, well, there's only one, so it will return also this one trade, but that's a more kind of flexible and powerful type of query. All right, any questions about the queries before we get to the web services?
No.
All right, so now we're ready with web services. Okay, so this is great, right? So let's close all of these tabs. Okay, and REST API, right? Okay, so first of all, again, and we've seen this picture before, right? So RESTful API and web app must be separated, because web app will work exclusively with the REST API. It will provide a single, it has a token to go through the security perimeter. And if we implement a change implementation here, database different and so forth, REST API can change, web app can stay the same. And on the other hand, if we make a new web app, but it works with the same REST API, our job is easier because we don't have to then build a new streaming adapter, new database adapter, and so forth. So it works better from a security perspective because there is only one app that accessing any, in other words, the web app is accessing only one thing inside the security perimeter. So it's a lot easier to detect or protect rather against unauthorized access, because you know that any of these apps should never be accessed from outside, right? So that's what we're going to do, but in our smaller sandcastle version. So the next hands-on session is Fast API, right? So there will be two, Fast API and request. So Fast API is how you implement RESTful services, and RESTful services is a particular protocol in which you have a exchange of data, and basically you can post data, you can retrieve data. So this is a set of conventions, and there used to be a tool called Swagger for working with RESTful services. Now it's called Open API. It has been standardized. So we're going to build Fast API and look at it just from the web page using this standard tool, which used to be called Swagger, and now it's called Open API. And the next thing is that we'll build the Python library for working, right? So this implements the web services, and this is using the web services. And then after that, we build a web page, right? So right now we're building the REST API. So first hands-on exercise is we build that. Second is we look standalone at the package that helps web app go to REST services. And then we look at the web package and build a rudimentary web page. All right, so Fast API. Okay, first of all, I put them in core, right? So maybe I should have put it in CMD, but I wanted to make sure that everything is in the same place. And the API is an API folder, and then there is a web folder for the web apps, right? So we're looking at API folder right now, and there's a web folder later. You will be looking at web folder later. So let's look at Fast API. So there are two examples here, right? So one is intro, and the one is blotter. So intro is just the introduction to how it works, and blotter is the RESTful service or microservice, right? Microservice, people used to build the giant services that has hundreds of request types and so forth. So later, the application philosophy evolved. And now the idea is to build a single service, a service that does one thing, but does it well, right? So does one thing, does it well, does it in a way that does not change often, And then it's the application becomes less fragile, and also it's easier to upgrade it. When there was a giant service, so many things could go wrong, right? So you have like hundreds of thousands of functions, and once you're doing a new software release, you have to, anything goes wrong with any of these functions, you have to roll back the release. When you're using microservices, which is that each RESTful service does only one thing, right? And if you have this single central, REST application, it just aggregates other services, right? Then it's a lot safer to do releases. You can, for example, if you have a trade blotter, which goes to a trade database and retrieves the trades for you to look at, if there's a microservice just with a trade blotter, you can upgrade it separately from the rest, from receiving streaming market data for pricing, from doing other things like looking at the users. So microservices is the architecture philosophy in which instead of one giant service, you have a lot of smaller ones. But you still don't want to have, you don't want to have too many places where the application goes. So you may have a service like here, which aggregates the services and provides a single, security verification for the access. What is better, Fast API or DRF? Okay, so basically we don't. I think Fast API is certainly more popular. And of course, there is always Django as well. Basically, it's a whole big mammoth of a package. So we don't endorse particular packages, open source or commercial. So we're using Fast API because it's popular, and I think it does the job. And for the web app, we're going to use Flask or Bottle, which are actually very similar, but we don't endorse any of them. And there are probably 10 viable choices for each of these applications. So basically, I don't want to go into detail because it's really a matter of opinion. All right. So any other questions so far? All right. So intro, right? So first of all, in Python, everything is incredibly simple when you develop, right? So this is a RESTful service. We're going to have a web server. Web, if this was in the cloud, would say endpoint, right? So now it's a server because it's on a local computer. So all you do is basically you just run a Python program. So the Python program will launch on a local host, and I selected the high port above 50,000. You can also probably be pretty safe selecting port 8,000, which is reserved for development. Or if you have several, you can go above 9,000. Still, there is a slight risk of collision with some other ports that do something. So, I'm just using the ports above 50,000, which are pretty safe, and it's like the wilderness that nobody's using, right? So the way that Fast API works is that, first of all, you create the Fast API, you create the instance of Fast API class here. Okay, so then you write a function and you provide it with a decorator. So decorator is a function that takes a function and returns a function, right? So this decorator provided by Fast API with the ampersand is the same as calling this function on that function, right? So you implement function getRoot, and Fast API takes your function and embeds it in something, changes it, and so forth, right? You don't need to know how. In order to make your function in Python become a service, endpoint, all you need to do in Fast API is to put this decorator, actually in most other frameworks as well. So this is a very simple function, right? So this is the path of the relative path of the, your URL. And we're just going to say, welcome to Fast API. And here, it's a little bit more complex. We have the root, the path with path params. It's just, that's the name of our function, or we can call it, get trades or something else. And we go, so this syntax means that we want this parameter to become part of the URL, right? So you know how, like, you have the URL slash, let's say EN-US means US English and so forth, right? So you can make some of the parameters part of the URL, or you can make them with a question mark, right? So let's just quickly see how this works, right? So this one makes this param1 and param2 part of the URL. That's the syntax. If you don't put them here, then anything that does not go here, it interprets as a question mark. And you can also have a function that throws an exception. And also you can replace this with post, right? So let's run this one and then we add post, right? And post, the difference with post is that in get, your parameters are part of the URL, either part of the path or variables after the question mark. By the way, only variables after the question mark can be optional, right? So in the path they are required. Post does not expose your variables as part of the URL. That's a good thing when you're sending something like a password or even a username, right? Which also could be sensitive and something that hackers would like to get, right? However, when you have the URL with get, then it's easier to copy and paste it somewhere. So basically, it's kind of it depends on the situation. You may have one or the other. So how you run it, right? Very simple, right? So you define these functions, you put the decorators, and there is something called UVcorn, which is your little local server that basically responds to HTTP requests. So I'm going to say run app, right? So that's the part here, localhost, and I chose the port for 300 for that purpose, right? It's just a port above 50,000. So run, and I can run it on the debugger, or I can just run it, right? So if I just run it, what will say is it started the server, then I click here and it opens it in the web browser. And it says welcome to Fast API because that's what the root message is. Okay, now in order to see what it does, right? It does not serve web pages. It serves web services REST request. And there's always for this standard, which used to basically that's a Swagger tool, right? But for the standard for the web request, there is this docs. Basically the standard is called Open API. Fast API implements it. If you go /docs, you get this type of a page. This page is provided for you to be able to study what the web service does or access it manually. So that's our get root function. And we already saw it, right? So you can say try it out. It does not take parameters, no parameters, execute. What do we get? We get welcome to Fast API, great, right? This is our function get with parameters. I click on it. It tells me which parameters are there. I go try it out. It says param required, right? So I will say execute. It will say no, does not want, right? So it shows me that the parameters are required. Both are strings, so go A and B, right? Execute. Okay, so what we see here in Swagger, first of all, we see how to call it, right? Localhost, that's our URL, right? So it could be Gmail or something, because Gmail also works on the same principles. With path params, that's our path. A and B, right? So when we put in the code this slash path param 1, path param 2, it became this path. So there is no question mark here. It's part of the path. And this is what it returned. Why did it return that? Because that's what our function returns, right? So we return JSON, which so in other words, our dictionary that we returned came back through the API, and we see it now here. Okay, and now there's another one with query params. So let's see what this looks like. Again, try it out. A, and this is optional, right? B, execute. Okay, so 1 second here. Okay, so what didn't I like? It's integer, right? So I have to do 1. So you check the type. So as you can see here, right? So now it's a little bit different syntax, more longer, right? So you have HTTP with query params, then there's a question mark, and then required query param equal A and optional query param equal 1, right? So this function has required query param, says this name, optional query param this name. So I put string here, and I put type annotation, which looks like this, which means optional, right? It's either int or none, and I put default value. Fast API read the Python function syntax and provided the implementation that corresponds to the syntax. For example, it says here it's integer because of this type annotation, right? So integer is coming from here. That's what I specified here. Optional, right? What it means is that I don't have to specify it. Say execute. What do we get? We get null, right? Okay, and finally, last one, right? So how to handle errors. Okay, so let's look at this function. example raising exception, right? So this function raises exception. It will raise HTTP exception with status code 418 and detail exception raised in Fast API. Let's run it. Get. Okay, no parameters, right? Try it out. Execute. What do we get? Exception raised in Fast API. Error, I'm a teapot. Okay, anybody knows where this came from? This is not in code, right? Let's look at this function, right? Anything about the teapot here? Okay, anybody who knows where this came from, raise your hand. Why is it saying it's a teapot? Any hands?
Well, no hands, but Pavel posted plus, so I suppose he knows.
Okay, anybody else knows?
Don't be shy.
Okay, it's a special error code for the teapot to inform you that if you're asking it to make coffee, it's a teapot and it cannot make coffee. This was added in the early days of the web. Everybody knows 404 code not found and so forth, right? So there is a 418 code which says, that basically if you go to the web standards, you'll say error code for 418. It's a teapot API. So basically it's a special error for the teapot that receives web services request to make coffee. And it says, I cannot make coffee, I'm a teapot. At some point, some person on the web committee demanded that all of the web libraries that implemented, right? So basically, this came from Fast API. Fast API actually implements it. I didn't write it in code. It's just this 14 code. It's actually that's what it means in the web standards. So somebody wanted to remove it, and then basically someone from high school started a petition which went viral about preserving the error code, just as a reminder that basically there are humans behind all of these APIs. So this is a legitimate web request and resulting in an error code, because if our application was a coffee maker, it will say, yes, I can make coffee, but it's a teapot, so it cannot. All right, so that's we learned what's code 418 is, right? So, okay, great. So, and I'm very happy that that there are people who actually are familiar with this. All right, so now that we learned how to handle errors, and of course, you can put basically, so you put the error code, right? So, for example, you may, for more serious applications, you can put 404, for example, not found, or some other things. By the way, one interesting thing is that if you know the Fahrenheit 451 book by Ray Bradbury, so there is a code for not able to display something for legal reasons. Like, for example, when there is like a takedown notice for some copyrighted content. So this is the code 451 in honor of Ray Bradbury, right? Because that's book is talking about the world where you cannot see a lot of stuff. So there's a lot of people who are creating the web are having a lot of fun at the time. Right. So anyway, that's our error message. Okay, and now we're ready to go to the real application, right? But let's just make maybe yeah, we still have time. So maybe a couple of changes here. So like for example, I can go and say so with query params, right? So I'm going to say get traits. I can say, for example, get traits by post. Use post. And this function is called use post, right? And maybe instead of an int, I put let's say maybe put float in default value 1.0, right? And after I execute it again, I will get the new function here. So it's as easy to change as just adding a function. Right, go to docs. All right. So use post, right? So for a second, did I change it? Sorry, my bad, right? So I say you post, right? But I forgot to change it to post. Okay, there we go, right? So now I should say post. I hope. Yeah, so you see it says post. Okay, so use post, the same thing. So now is a default value 1, required query parameter. So if I say try it out, I can say A, but the default value will be 1. And we get this default value of 1 because I didn't specify. First one I specified equal to A. But as you can see here, the actually 1 second. So request URL. You know, I'm a little surprised actually. It's still showing the parameters like that because for both actually they're supposed to be hidden. Anyway, so I'll look it up later. I thought that it would not do this because actually the whole point of post is that the parameters are hidden. But in any case, I think hold on a second. So maybe. Yeah, you know what? Let me just take it away. I think that it may be that if you're doing this, the parameters are still passed as part of the API. You actually need to send payload separately for it to be hidden. So I didn't realize it works this way. Anyway, so as you can see, it's very easy to add functions. And with that, we're ready to actually build a bloater. Right? So let's go to the bloater. So we're just going to combine what we already learned. Right? So we have a function create traits. We have a function. Well, there's a function create traits. It simply creates random traits. And it creates trait count, so how many traits we want to create. Okay, so then we build a function called add traits, and we can specify how many that creates traits and writes them into a database. Right, so it says to trait objects insert. By the way, that's how I mentioned last time that I will show you how to insert bulk. Right, so I'm not inserting records by one by one. I'm inserting them all at once. Okay, that's a function that just drops the database, right? It clears the traits from the database. That's a function that gets one trait, and that's a function that queries and gets all of the traits. And you can specify optionally the currency, and it will return it, if the swap involves this currency if you specify it. Otherwise, it will return all traits. And here's our typo there. Okay, so now let's run this thing. Okay, so go to docs. Okay, first of all, let's see if we can query traits, right, and see what we get. Try it out, execute. Responses. Okay, so we have some traits in the database. Why? Well, because we kept them in the database. You know, see that they're still here after the test, right? So there are 2 swaps, and we return them. Okay, let's clear them, right? So you can see that it's fresh data in the database. There are traits. Okay, so we're going to go back to the Fast API and execute clear traits. Try it out. No parameters. Execute. What did it return? Success. 2 traits cleared from DB. So it went. When we did that, it went into the code, calculated total count, dropped the database, deleted everything. In Mongo, if you drop the database and you just tried writing it later, it just create it automatically, so you don't have to create it, unlike in SQL. It says success, total count, right? So it first got the count, then cleared the trace, and then provided this error. The success message for them. And if we go to the database and refresh data, we should not see any traits or data, right? It disappeared. Okay, now let's go and insert some traits, right? But I can actually, let me just insert them, right? And I'll show how to run through the debugger. Right, so in order to insert it, again, go to the Fast API, create traits, add traits, sorry. All right, try it out. Let's add 100 traits, execute. All right, so what do you say? It says success added 100 traits. DB now has 100 traits, right? So this could be different if some traits already existed, right? So now there's a tree. How many traits do we have in this table? 100 documents, right? So we have 100 traits. Great, right? And now we can go and retrieve it using the get function, query trace function. And for that function, let me show how to debug, right? So first of all, I'm going to stop the application, right? So I'm going to stop when you're running it like in PyCharm like that, right? You can just simply do this and do that, right? So it will ask you to terminate if it's running. Okay, I'm going to now run the same thing, but on the debugger. So I'm going to simply set the breakpoint in this query trace, right? And I will launch it under breakpoint. So now I can also click on the same thing. So I go to docs. That's how you access, right? And let's go to query trace. So post, right? And now let's see. So I have leg currency, right? So let's assume that I want to try it out, but I'm going to specify currency GBP. Execute. So what will happen now? It will waiting here, and my PyCharm is flashing to alert me that the debugger is stopped at the breakpoint. So I'm now here at the breakpoint, right? So my leg currency is GBP. That's what I specify. If leg currency is not none, it will go here, right? So I step through debugger. I'm going to have leg currency passed at the query and get the trades. Okay, I got the trades. So what are the trades? Trades is a query set returning 29 trades. Okay, great. So now I'm going to do this, and this thing will iterate through the request and convert each trade to JSON, pack it into an SL list, and I can't return a list. So it will pack it into a JSON with a single dictionary with a single element called trades and return, right? So, and now if I let it run to the end, it will come back from the API call and show me 29 trades. So this is how it's easy to debug it. Of course, you don't want to run this type of server in production. It has this type of warning, like, like the Superman costume does not really let you fly, right? So this thing says don't run it in production. I think it's pretty obvious you shouldn't, because it has no security and so forth, right? So this way of running it locally through UVcorn, right? So this all just for development. Okay, and with that, let's now go to, and so we need to accelerate a little bit. So let's now go to the second hands-on exercise, which is to how to use the API, right? So we implemented the API, now let's see how to use it. Right, so in order to use it, again, so this is the intro, and I will just go directly to Blora because it's really not much harder, not much more complex than that, right? So request is a library, you import requests, and all it does is that you specify the URL, in this case, localhost 301, that's our query trace function. You go request post or request get, right, the URL, and you return the trace. So in this case, I did not pass any parameters. And in this case, I pass one parameter where leg currency is GBP. So it will do two things here. It will get all of the trace here. It will get the GBP trace here. And it will get the trade with the trade ID equal T3 here. So this is the library, which is the exact equivalent of going to this front end and executing it manually. In fact, you can actually more or less copy paste whatever the Swagger tool, OpenAPI tool shows you about the request. You can copy paste here, but the parameters have to come here separately. So if I run it, it will print. Sorry, well, step in the debugger again. Okay, yeah, because you see, it's still step in the debugger because what I'm doing right now is I'm running two separate applications, right? I'm running a fast API. I'm running the application that accesses it. So it's still stopping the debugger. So let me clear all these debugging breakpoints and run again, request bloater, right? So actually, a second. Right. So it printed all trace, right? So that's a very, very long, as you can see, very long JSON all in one line. Then trace leg currency is GBP for at least one leg. Well, before we had 3 trades, and for them one had GBP, right? So now there are 100 trades of them 29 GBP, right? So it's a shorter JSON on the second row. And trade with a trade ID T3. Well, that's only one trade, trade number 3, right? So all it does is that it basically does the same thing as Swagger. It forms the URI request and it returns the result. Of course, there is a lot more to it. There's error handling and so forth, but that's the functionality we need. And with that, we're ready to go to the final and very basic web application. So there are 2 frameworks. Again, we're not endorsing any frameworks. There is a grandparent of everything, Django, right? There is Bottle and Flask, right? So Flask is actually, well, Bottle is kind of a newer framework that's used to be Flask, Django and Flask. So Flask is kind of does a limited more limited things, and Django, is a more comprehensive framework that uses the same type of code. And Bortle is kind of, well, Flask and Bortle are similar words, right? So it's a new framework that kind of play words on the same name, right? So they're extremely similar. I built like one example on each. So let's look at Bortle, right? So in Bortle, first of all, you import Bortle, you go Bortle debug, Bortle route, right? And it says welcome to Bortle. And you run it, so all almost exactly the same. Each run on a different port, right? So run URL, welcome to Bortle, right? So localhost port 5100 that's where you specify it, localhost port 5100. It has the route of the root URL in a function get root page. Returns welcome to Bortle, Flask, right? Same thing. Import Flask. App is, you have to create an instance of Flask application. The rest is nearly the same. Welcome to Flask. Okay. Right. So now let's look at the bloater. All right, Bortle bloater. So instead of the hello, welcome to to Flask, we're going to form a little web page. In production applications, there is a template engine for that. So Flask has its own, and there is basically template extension, the TCL, that you use for that. Sorry, Bortle has its own. And Flask uses something called Jinja, right? So Jinja, or Jinja 2 rather, is a template engine. Essentially, the way that template engines work is that you start from a web page that you display verbatim, and you specify some Python here with some surrounding tags such that HTML thinks it's a comment. Actually, sorry, correction. HTML doesn't think it's a comment. It's removed from HTML before it's interpreted, right? But the idea is that Flask and Bortle go inside HTML, find this specially annotated snippet of Python inside, interpret this Python, execute the Python, and this makes web page bigger. And this is a more kind of a neat and easier to use way compared to what I'm doing here, which is I'm forming the string for the HTML by hand. So you can always form it by hand. It's easier to do it with a template, but we don't have time. We're running out of time as it is, right? So we don't have time for the template action. And of course, I'm sure know about frameworks like React, Angular, and others for building front ends. So these are JavaScript frameworks that make it possible to have what's called a single page application, the web page that never reloads and behind the scenes makes calls to RESTful API and substitutes or changes the data inside the page without reloading the page. That's why it would be pretty annoying if your Gmail was loading every time that you click on something. So it's probably already 20 years since web apps stopped doing that, right? So the early when the web appeared. By the way, I worked in a software lab where Mark Andreessen, you probably know who he is, right? So he's the inventor of the web browser. I was working on his secret web browser project, Materials Research Lab in Illinois, where all of the professors were complaining that he's not paying attention to what they need for the experiments. So basically, at the time, the first web pages were, very, basically they would reload every time, and our page would reload every time. But of course, in modern frameworks, they don't, right? But again, this is not about JavaScript or React or Angular. So we're just going to form the web page, and we're going to do it quickly. So this is the page and table header, right? It has the head. This is Bortle Trade Bloater. It has the table columns here. Then there's a footer, and between header and the footer, right? So we're going to return header, footer, and table rows. We're going to query the data. We're going to use request to query the API, right? So the key thing again, so remember the diagram, right? So we're not going to the we're building the sandcastle, right? Not the castle. So our sandcastle, however, has separate towers, right? So we're building the web app. It does not go to the database. It goes to REST API, which goes to the database. So I will need to run both the FAST API endpoint and this one, such that the browser goes to the portal application, web application. Web application uses request to go to the Fast API application, right? And it has this, setup, basically a setup API URL to point to the Fast API application. We will then form a table row from whatever this web service, RESTful web service returned, and execute, right? So, and let me run it, under debugger, right? And again, so I need to make sure that this thing is running, right? Just make sure it's running. Stop and rerun. Okay, it's running, right? And otherwise that one would not work, right? So let's go debug. Okay, and now we have two pages, right? So we have one page right here that stopped in a debugger, right? So we got the API URL pointing to Fast API. We got the dictionary of traits with 100 traits. We got the list of strings. So now we're just retrieving the data, right? So we got the dictionary, we got the list of strings. And now each of the elements here is not an embedded dictionary, but strings. So I need to convert it to JSON. And now I'm finally able to go get trait rows, right? So it will now produce trait rows. So table rows is now the string with the table, with the HTML for each row of the table. And I'm going to combine it with the header and footer here. And now let it run to the end. And now my web page will return the result, right? So this is a trait blotter. So it has columns trait, currency 1 and currency 2, and retrieve this 100 traits. I could have put a total here, right? Okay, Flask, same thing exactly, right? So already running Fast API. So I'm going to run Flask. This time I will not run the debugger. So it's active. So I have the web page. So this web page also displayed the traits. What I did is that I went to port 5201. The application inside went to port 5301. So web app executed, use request to go to the RESTful service. The RESTful service went to a Mongo database, and we have Flask and Bottle web applications here for you to enjoy. All right, so that concludes the main material of the lecture. We're actually almost on time, right? So in fact, we started a bit late, so we're exactly on time. And I will ask now for questions, and it seems like there are a lot. And then please stay on because there will be information about the certificate. Okay, so April's Fool, right? So guess, okay, so this all.
There are no questions, just
yeah, okay, microservices, yeah, right. Okay, somebody answered my question. Yeah, okay, right. Yeah, actually, I agree with the answer, even though again, as I said, we don't draw stuff. So with that, let me go to conclusion and certificate. So during this course, again, so this was not the course about Python syntax. I assume that you know that. But this is about how to use Python for certain aspects of enterprise software development. We covered as much as we could in 4 days, of study. And we started from package structure, conventions, test frameworks, PyTest, approval tests, and so forth. Working with complex data, and specifically using object document mapping and object relational mapping. In the frameworks, data class, address, pydantic, and the ones that are implemented by Mongo Engine and SQL Alchemy. Regretfully, they're all different, but eventually I think they're already starting to converge around data class. Working with data classes, data types, and basically working with data in different ways to build the schema, depending on database type. And finally, database queries. Today, we covered database queries, implementing RESTful APIs and building web apps around those APIs. And our sandcastle, even though it's not like a real castle, but it has 2 towers, right? One for the web app and the other one for the RESTful service. So it's not like, the simple hello world that goes directly to the database or produces dummy data. So we built, something that has the elements of a real app. All right, and with that, thank you for joining the course. So we're offering a certificate for completion of the course. But the certificate is only offered if you pass the quiz and do a simple practical exercise. So, I know everybody is busy, so if you don't have time, that's fine. However, we would like everybody to answer a separate quiz where we will ask you to tell us, we choose between several other courses that we, are thinking of offering. So if you're interested in a particular course from CompatibL, also in a similar format, actually, correction, similar format in the summer. And one of the questions was when the studies start, because I know many participants are students, whether the same format would work or whether you need maybe a shorter lecture, but more lectures, but then each one shorter. So that was one set of questions, how to do it properly during the semester, during the study, from September to the spring. And we will have several courses to choose from. We would like to get some votes of what is most interesting. And if none of them are of interest, there will be a field for you to type what course you would like to attend. And we'll certainly consider your interest and preferences and planning our course schedule for this year, for the rest of this year, and for next year. And for the certificate. So the quiz will be topics like, for example, like here, is JSON. How would you put it in a relational table, right? So in other words, it will be a multiple choice question where you can simply, it will not take a lot of time. There will be a multiple choice set of questions about, how to do something that you studied in the course. And for the assignment, we will ask to fork our GitHub project, which is on GitHub at basically github.com/compatible/enterprise Python, and change the code a little bit. We estimate that it should take about half an hour to do it. We will not going to ask you to build a massive castle. It will be just a small change to the existing code. So these two things, basically, whoever passes, will review the code. We'll try to help, if there are any questions, but of course we cannot do the assignment for you, but if there are anything not clear, we will help. None of it is using any commercial software, so you should be able to run it all with open source, packages. And we will, to those who successfully complete, the quiz questions, or most of them, and does the assignment, we will offer a QR code based certificate that will be basically resolving to a web page where you can confirm that you received the certificate successfully. All right, so thank you very much for joining. It was a pleasure teaching this course, and I hope we'll see you again at future courses from CompatibL.
Alexander, please do not disconnect so far. I will also answer a couple of questions the guys are asking. So yes, you will receive a dedicated newsletter from CompatibL training team with the links to download the course materials and the links to recordings that will be placed on YouTube. So that's my answer to your worries about access to materials and course files. Then passing the quiz again on Monday, you will receive a newsletter from CompatibL training team. Please watch all the emails you receive, and there will be details, instructions, and links to the theoretical part and this small coding assignment Alexander has just described. So we will be in touch with you during at least 1 week or even more. It will be about the materials, it will be about the quiz, then it will be about the quiz results and certificates, and there will be also a survey. Just we really want to know your impressions, what you liked, what you didn't like, how to improve our courses, and what to add and offer. So feel free to email training@compatibl.com if you have any urgent questions now, or just be in touch and watch your mailbox.
Right, and also one last thing. So we're looking for Python engineers. So if you're interested, if you're looking for a job, please get in touch. jobs@compatibl.com, or you can use the.
Not exactly like this. I'll just type the URL.
Actually, no, okay, sorry. Right. Anyway, so Anastasia will type it, or you can contact the training team and they'll put you in touch. So we're very interested in working with you. We have an interview process. We promise very interesting projects. In fact, we're putting together a team for building a new library for mathematical finance, and this is going to be very exciting. So we hope that you'll consider us as a potential employer. And with that, I think we covered everything. Anastasia, anything else?
Well, just a small add-on. So it's not only about full-time jobs for like super experienced developers that you will be just like, oh, I don't have such an experience. We do also have opportunities for students or fresh university grads. So please do not hesitate. You can, of course, check the job descriptions that are listed on the website, but please do not hesitate to email us with your CVs and details, either to training, so we identify that you are from this course, or directly to jobs@compatibl.com. And yeah, we're very open to students and fresh minds. And whether you prefer working from one of our offices, and we have plenty of them, or from your home office or any co-working space, CompatibL is also very flexible in letting you do so from any location in Europe. So if that's also something you are considering, email us.
Thank you. And I promise this will be a very interesting project. Right. So with that, thank you for joining. It was a pleasure, and hope to see you in the next course.